Welcome everyone! In this video, we will solve a few problems involving sets. In the case of sets, we are often interested in how many elements are in the union of the given sets. The logical Sieve formula is a formula that helps in determining the number of elements in a set. In the following, we will explore the logical Sieve formula for the case of 2 sets and 3 sets. Let's start with the case of 2 sets. Let's have 2 sets, A and B. We are interested in finding how many elements are in the union of A and B. Let's start with the set A and list all the elements in set A. Then, add all the elements in set B. Notice that the elements in both set A and set B have been counted twice, those in the intersection of A and B. These elements are counted twice, so we need to subtract one instance of the intersection element to ensure that the common elements are counted only once. Now, we've counted the number of elements in each part, and each part has been counted only once. We are done. Let's look at an example. In a parking lot, there are motorcycles and cars, with 12 motorcycles and 20 blue vehicles. How many vehicles are in the parking lot if 6 motorcycles are blue and 8 cars are not blue? Let's see the solution. Let's define 2 sets. One is the set of motorcycles, and the other is the set of blue vehicles. It's not correct to separate motorcycles and cars into 2 distinct sets because whatever is not a motorcycle is a car. This way, the 2 sets would not have an intersection. Therefore, the 2 sets are the set of motorcycles and the set of blue vehicles. Let's look at the number of elements in the 2 sets. We know that there are 12 motorcycles, which is the number of elements in the motorcycle set. In the other set, there are a total of 20 vehicles. The intersection contains 6 blue motorcycles. These were counted twice, once in the blue set and once in the motorcycle set. So, we need to subtract 6 once. Thus, there are 26 blue vehicles and motorcycles in the parking lot and 8 cars that are not blue. In total, there are 34 vehicles in the parking lot. Let's look at the Sieve principle for the 3-set example. First, we have 3 sets, A, B, and C. Let's start adding the elements. First, add the elements of set A, then the elements of set B and set C. Let's move on to the sections of the set. We have included the elements of the intersections in all sets A and B, in set C and A, and all in sets B and C. It can be seen, for example, that the intersection of B and C is included in the circle of set B. Since this is true for all circles, each intersection is counted twice. For this reason, the element count of an intersection must be subtracted from the element count so far. Let's move on to the intersection of the set A, B, C. Here all 3 sets have elements in common. This was included 3 times in counting the set A, B, C and then subtracted 3 times in the intersections. So now the element number of the common intersection is not included in the total element count. This is easily remedied by just adding it to the other elements. This will complete the total element count of the diagram with 3 sets. Let's see the animation again. Count the number of times we have added and subtracted each set part. Let's look at the problem. An ice cream shop orders 20 chocolate, 15 vanilla, and 8 strawberry ice creams in one day. We also know that 7 chocolate vanilla, 2 vanilla strawberry, for chocolate strawberry, 1 and 1 was chocolate strawberry and vanilla. How many cones did the seller sell if we know that 12 cones have no chocolate, nor vanilla, nor strawberries? Take 3 stacks. One will be chocolate, one will be vanilla, and the third will be strawberries. Since there are ice cream variations, there will be intersections between the stacks. Our objective is to determine what the total number of elements is in the union of the chocolate, vanilla, and strawberry sets. We know that 20 scoops are chocolate. 15 vanilla and 8 strawberry ice cream scoops were sold. In the chocolate-vanilla intersection, there are 7 elements. In the chocolate-strawberry intersection, there are 4 elements. In the strawberry-vanilla intersection, there are 2 elements. And in the common intersection of all 3 sets, there is 1 element. Let's not forget that the intersection of chocolate and vanilla was counted twice. Once when counting chocolate, and once when counting vanilla. Therefore, this intersection must be subtracted. The same applies to the other 2 intersections. Now let's focus on the common intersection of chocolate, vanilla, and strawberry. This common intersection was included when counting chocolate, vanilla, and strawberry, but it was also included when the chocolate-vanilla intersection was subtracted, as well as in the other intersections. So, we counted it 3 times and subtracted it 3 times. Now, it is not included at all, so it needs to be added back. Let's see how to fill in the 3 sets and their intersections. It's important to always work from the inside out. We know that there is 1 element in the intersection of all 3 sets. In the chocolate-vanilla intersection, there must be 7 elements, but 1 is in the common intersection. So, 6 remain outside. In the vanilla-strawberry intersection, there must be 2 elements. 1 remains outside since 1 is in the common intersection. In the chocolate-strawberry intersection, there must be 4 elements. Since 1 is in the common intersection, 3 remain outside. There must be 20 chocolate cones, but we have already placed 10 in the intersections, so only 10 chocolate-only cones remain. For the vanilla, there must be 15, leaving 7 outside. For the strawberry, there must be 8, leaving 3 strawberry-only cones. This means that the ice cream seller sold a total of 31 cones that contain chocolate, vanilla, and strawberry. However, there are still 12 cones left that did not contain any of these flavors. So, a total of 43 cones were sold that day. With this, we have reached the end of the task. Thank you for watching the video. If you found it helpful, don't forget to subscribe. Be sure to check out the other videos in the course to continue building your knowledge. See you next time.